Right. So last time we discussed what our expectation from advanced software design module. As the first part, I expect you to understand the different software design methodologies. So depending on the problem at hand, and also depending on organizational culture, you may have to decide on which software development method you are going to use. So that's the first understanding. We were discussing about structured analysis last time. So let me start with the object-oriented analysis, and then we can move on to the newer software design methodologies like Agile, right? Okay, to start with the object-oriented analysis, I hope you have already done object-oriented designing, right? Right. And you know that in object orientation, we talk about objects and we talk about their relations. So we can use objects to represent things, could be humans, could be other things, could be even the events. And then you can have properties, what you want to record, like what we call data members. Like, for example, if you take, let's say, student object. So we would like to have your name, your contact details, and so on. So those will be the properties. And then there'll be some actions. So those are called methods. And then when you want to interact with the other objects, we can use messages. So message could activate some of the methods inside in other objects, right? So that's how the object orientation works. It's similar to a traditional software development lifecycle we have discussed last time as well, right? Okay. The simple ideas that we actually normally discuss under object orientation. For example, let's say we want to represent, a student. So as you can see here, we have a student class. Usually we have three parts. We have set of data we call properties, and then we have other properties as well. But normally you will have methods as well. So usually you will have three parts. You have class name, and then you have set of attributes and the methods. And this diagram actually what it shows you is there's another class which we call instructor here. And then there will something called a superclass. Usually when you have common attributes, we can put into a superclass. For example, irrespective of whether you are a student or an instructor, we can have name, address, and date of birth. So they are common usually. So if they're common, we can put into what we call a generalized class. We call it a person in this particular example. So what happens is when you have this information in the superclass and we have subclasses. So this is called superclass subclass relation. And you will see that these attributes or properties in this particular case are what we call inherited. That means whatever you have in your superclass will be available for the subclasses. So that's same for all the attributes and the methods, right? So you can notice in this particular example, we have a student and an instructor, and the name, address, date of birth is actually inherited from the person. And then there could be other properties. So that's simply what you see in this simple diagram. Right. Even in object-oriented analysis and design, and especially object-oriented analysis, you will see very similar phases, similar to structured analysis, what we have seen earlier. We have 5 phases earlier, and here also we have similar phase. So we have planning, analysis, and design. And you can see it's a iterative process. So you see a circle here. So these phases are iterative. And then based on the designs, you can have prototypes, that means working models. and then you can actually test them. So this is what you notice in object-oriented design. Right. So that's about the a very brief introduction to object orientation. I think we have discussed more detail last time, and also you have another module going on. So I hope at the end you will have a good understanding. But apart from that, I would like to have a very small assessment based on object-oriented principles, so that we can see your understanding of basic object-oriented principles. This understanding is very, very important. For example, if you want to learn more advanced, software design, what we call design patterns, because so based on object orientation, we can talk about some common patterns, and they are called design patterns. So I'll come to that later on, but first of all, we need to have the basis right. So therefore, we will first look at the object-oriented principles first. And once you're comfortable with that part, we can talk about the design patterns. Okay. So let's move on to the more recent software development strategies or methodologies. So Agile is one of the newest, what we call the software development approaches. And the idea of this is you are not going to build everything at once. And then you are going to do it what we call incrementally, right? And also one of the things is you are focused on your users. So therefore, you are going to develop incremental fashion, and you are satisfying user requirements, right? Which means that so your priorities might be based on your user requirements. So Agile, therefore, we can say it's in a spiral model. You will have series of iterations or revisions, which are based on user feedbacks, right? So it might produce series of prototypes, and then finally that can evolve into your final product, right? So two particular Agile methods I would like to discuss today. Which we call Scrum and Kanban. So I'm going to visit those two in a little bit more detail. Right. So let's start with the Scrum. So as this simple graph shows, Scrum is one of the example for Agile methodology. And we are using some specific terminologies which might be similar to what we have already heard. And there are some set of players or roles here as well, right? So for example, if you look at the key concepts in Scrum methodology, so we have talk about three roles. We have product owners, which are the person who is actually responsible for the product. That means basically he's the one who actually defining the features of a product, and also like prioritize them, like what to be implemented first and so on. Then there'll be another role called Scrum Master, which means there is a process here which we call a Scrum, or we call Scrum process. So that role will facilitate this Scrum process. And then and Scrum Master ensure the development team follow the practices and remove any obstacles or any issues might prevent development of the product. And there will be a third role we call development team. That means you have a various different professionals who build the product. So it's not a single person. Usually you have a set of people who works as a team. So they are the ones who are actually responsible for delivering the product. Right. And then there are few things. You will notice here something called product backlog, which means this can see as a set of features that you are planning to implement, right? So let's think about, let's say, let me take an example. Let's say we are going to develop a student management system. And then we have to have set of features like registering a student, enrolling a students to course, and so on. So we have a set of features like that. So those things you can think of as a product backlog. It's a, we call it, it's a prioritized list of tasks or features, right? And then we have something called sprint backlog. That means you are going to select one or two, and then you are going to, that you are going to develop. So out of the set of features, so you are going to select a set of features to be implemented for a particular duration, right? And then, so this happens in a various phase we call sprint planning. But let me first explain what a sprint is. So sprint is the term that we have used. That means you have fixed period. So usually this period we call 2 to 4 weeks time. So 2 to 4 weeks time, the development team focus on implementing a set of features which we will agreed in this what we call the sprint backlog, right? And this is decided in what we call the sprint planning time. So that means before you implement, you will have a meeting at the beginning, and then you are going to decide which task you are going to implementing during this spring time. That means during 2 to 4 weeks period, right? That's basically the idea. But within this period, now you see you have a set of features, and during a sprint planning, you select a subset, and then you are going to implement this subset within a time frame. And within the time frame, then we have very short meetings, right? We call you have daily meetings. The idea is the team will discuss the progress, any issues you might have, and the planning, right? I'll come into detail. And then once you finish that, we have a sprint review. That means after finishing this sprint, the 2 to 4 weeks time, and then you are going to talk about what you have completed. So you might complete, you might not, depending on the problems you might faced, right? And then sometimes there are events like what we call sprint retrospective, which we call what we call the meeting after the review meeting. That means like you discuss what went well and what could be improved. So these are the basically ideas that you will come across with the Scrum development methodology. So you can see it's very high iterative, meaning that software development is bounded into a smaller time frame, usually for 2 to 4 weeks time. And the product development happens over the time. And always you will get the feedback from your stakeholders, mainly from the end users, right? Okay, so I basically discussed this one. The idea came up in around like 1986, and then it was popularized in 1995, and especially this came into a picture around like 2010, right? So the idea is, handle very complex problems. Especially nowadays, user requirements are changing. So when you have a volatile or dynamic, requirements, our traditional methods will not work. So that's why Scrum got very popular. And the main principles is like you make informed decisions, and then you talk about the transparency, inspection, as well as adaptation. So the practices, as I discussed, that you have a planning stage, and I already described this, where you decide on what features to be implemented. And the sprint, I told you, like it's a 2 to 4 weeks time frame. And then you have a daily scrum, which means meeting within this time. So this is called the daily sprint. So usually it says about like 15 minutes. And the idea is you will ask from each member. Usually you have a scrum master, I told you. Scrum master asks each and every individual in the development team, what is your plan today? And once you know your plan, then you will discuss what are the requirements and what are the issues. So this will be there, right? And then as you finish your sprint, you have a sprint review where you talk about the product. And the retrospective, I told you about, like you reflect on what went well and what went wrong. Right. These are the roles that I have explained. We have three roles: product owner, scrum master, as well as development team. Right. Now, another thing that we need to discuss. So how do you measure the success in a situation like this? So metrics is we use we use to measure the success of our project. So it's called velocity. So that means measure the rate of progress based on the effort estimation during the sprint planning. So for example, you decide on for example, let's say to implement a particular feature, how long it will take. And then once you finish the sprint, the fixed time box, how much you have finished. So this is what we call the velocity. So that can be used for indicator for the future planning. So simply this is what will happen in the Scrum Agile process. Right. Any questions on that part? Any one of you are already familiar with this, and have you practiced it? Some of you, if you have been in internship, anyone in the class? Okay, it might be new to you, but I hope when you start your internship, you might be practicing one of these, and then you will realize the implementation of this. Okay, so let me explain the second one, the Kanban. The Kanban actually one of the Japanese term we use, which we call, so there's meaning for this. Kan is a signboard. Okay, so the word Kanban is called the signboard, and you will see usually you have a Kanban board we use. A visual board we use. We normally call this is Kanban board. It's a visual representation of project. So there are some tasks that you will notice here, like in different colors. And the idea of this Kanban is you can visually see where you are, right? When it comes to software development, this could be used, for example, to track the progress of implementation different features, right? So that means what are in the ready state, what are in the build state, what are test state, and what are in the deployment. So those can be specified. And the idea is, this is the start, this is the end. We are going to limit number of tasks in the middle because we know that this might be, if you have too many tasks here, that will be, problematic for the development team, right? So what you need to understand is Kanban is visually represented, but where we can have tasks, we can organize it like this. For example, although I have put in the graphics. In simple manner, we can say we can have columns like to-do list, progress, and testing and done. Likewise, you can have. And then you have limits, what we call a work in progress limit. We call WIP limits. So this term we use how many tasks that you can have in each of these stage. So as I told you earlier, you are not going to have too many here. So you have put some limit here. For example, when you say build, the WIP limit for 4, that means you can have maximum of 4 tasks in this slide. And when you say 3 here, the limit for test, maximum of 3 class is here. So that's the idea. Idea, as I told you earlier, is you are trying to prevent any overloading for the team members, right? So that's the idea. So so this is slightly different from the Scrum that we have discussed, because I told you in a Scrum, it's a very iterative and you have fixed time. And Kanban, you don't have something like that. It's continuous. So we normally it's called continuous delivery. So sometimes you might have seen this continuous delivery. So it's promote the idea of continuous delivery. So you can start, task at any time, and, it can end at any time as well. But only problem is, so you have limits in between, right? So the idea is, so that this is the limitation here. So once you complete a particular task, then you take a new task. Then it starts, right? So the set of tasks here, like backlog, the term that we have used in the Scrum. So you can take one and you can progress it, right? So usually we use terms like pull task. For example, when I want to start a new task, you pull task from ready to build, right? That's how it works on, right? So depending on the capacity, depends on the availability, then you are going to take, because you pull the tasks. So that means you have a time from going a task from ready state to deploy state, according to my graphical visualization. So the time it takes a task to going from ready to deploy, we call a cycle time. So the idea is you are trying to reduce the cycle time, right? So doing so, you can, start more tasks and finish it in earlier, right? So that means you focus on faster delivery. And then it also encourages the continuous improvement as well. So that means you can look at the cycle time. So let's say you take task 1, you can review, how long it will take to finish that time. You take the second task, you can see how long it will take the time. So then you can review, right? You can look at, cycle time, and based on that, you can encourage your team members to reduce the time. We call throughput, right? So the idea is you identify any problems, we call bottlenecks, or any inefficiencies within the process. So that's the basic idea of Kanban. Right. So if you look at the overview, it's coming from the Japanese. The originally, actually, it's put into a car manufacturing. It's been developed in Toyota in 1953 to improve the manufacturing. But then it was adapted to IT industry around like 2004. The idea is you can visualize, and many of our software packages now offering Kanban boards. Even you can find some plugin in the Google, where you can collaborate with your friends. Right. The principles, you start with what you do now, agree to pursue evolutionary change, respect current roles, responsibilities, job titles, and encourage act of leadership at all levels. So where we have some limitations, as we can see, and that's the way you proceed. So in Kanban, the visual board or Kanban board we use to represent task and their status. So one of the advantages you will see is you can visually see the progress. And then each column you can specify some limits. So this is not to have too many, work in progress task. And then you have to manage the flow. You have to monitor how they move from one place to another place. And I told you, you look at the cycle time and you can look at that and you can see any problems. And then clearly define the process and the rules, how you should move from one class, from one column to the other class. And then you have feedback loops. You can review the process. You can get the feedback from your stakeholders as well as the team. And idea is you improve collaboratively and evolve experimentally. So you continually improve the process through collaboration and experimentation. Right. So example, as I discussed early, you can have various stages and it's not fixed actually, you can decide. So as an example, you can have a to do, that means task that you at hand, progress, and then done. So it could be simple like this, right? Okay, so I didn't explain this earlier, but even in Kanban also you can have some roles. It's not very explicit, so therefore you don't see like in Scrum. Scrum actually they have explicitly defined their roles. But then you can have some common rules in Kanban. For example, we can have service delivery manager, which can be used to ensure the flow of work, and service request manager, where we can have orders and prioritize work items. So this also we have discussed when you want to measure the success of your project or product development. You can use cycle time taken from task from the start to finish. The throughput is the number of tasks completed in a given time period. So you can use these two to measure the efficiency of the process. Right. Now, if you ask to compare the two methodologies, and there are many others, agile processes, but we discuss only these two. But if you compare these two, the main differences are Scrum, you have time base, you have a time limitation called sprint, which is, I told you, it's 2 to 4 weeks time. Whereas Kanban, it's a continuous one, right? And roles, Scrum, you have a predefined set of roles, right? Remember we discussed product owner, Scrum Master, development team. So it's very, very precise roles are there, but Kanban you don't have. Then you have limits. For example, Kanban limiting work in progress. And then, whereas if you look at the Scrum, it's focusing on completing the task. And Scrum, we use velocity to measure the success. In Kanban, we can use cycle time and the throughput. So I hope now you have understanding about the Scrum as well as Kanban. Right. So those are the two main things I wanted to discuss. But if I go to talk about a little bit more on what is available, we can discuss on other methodologies as well. There are many methodologies developed over the time. So for example, team-based strategies like joint application development and rapid application development. Some of the development technologies where they focus on improving application development. Right. Regardless of what development methodology you have used, right? The project management comes and it's very, very important. So therefore, any software development project, you will have a project management component because you have to manage the time as well as the cost. So you have to manage efficiently if you want to optimize software development. Right. Now that we actually discuss about the development aspect of this, so let's discuss about the testing aspect of this. So we discuss about the initially what happens, then we discuss about the development, then the testing. Now, what happens over the years, software getting very, very complex, right? And this is very complex compared to 10, 20 years back. So therefore, now we consider testing is as an essential component, or we call it as a very critical phase because of complex nature of software system. So therefore, Agile and DevOps also transform testing processes. So early days, the testing was separated from the development. So you know that we have a separate team. So development, we have a separate team for testing. But with the ideas of DevOps, for example, development and operations are put together because they have understand that you have to go in hand. Therefore, nowadays we talk about continuous integration, continuous deployment, or we call CI/CD, or we talk about the pipelining. So that means we have automated. Once you have designed something, you test and develop. So any software you develop nowadays, you might see these three phases. What are the three phases? You have design, you have test, you have deploy. All through comes together, and most of the time it's automated. For example, I think I have it in some other place. We talk about the GitHub actions. I actually listed this as an example. So when you talk about the continuous integration, continuous deployment, you can automate the process, right? But before move on, I have a couple of questions. Okay, so we discuss about the continuous integration and continuous development, and I told you like GitHub Action is one of the technologies we could use to automate this process. Then we discuss about the cloud and containerization, especially Docker. It's a common practices nowadays. Right. Now in this one, we are talking about the types of testing. Unit testing meaning like you take individual unit and test. We call fundamentals, or you can use frameworks for this. And even language like Python come up with some basic testing. So docstring and doc test, for example, doc test especially could be considered as unit testing. Then we have integrated testing, which we talk about like among multiple items, we can talk about the integration and how they integrate together. We can focus on that. Third one, automated GUI testing. So nowadays you can test on interfaces, web interface testing. Fourth one, security testing. With the growing security threats on the systems, we have to check our system for security as well, whether there are any security vulnerabilities in our code. So therefore, you have to perform what we call security testing. Then performance testing, especially now, let's say you have a website, if you're expecting millions of users, whether you can, your web, web website can handle, millions or billions of users. Very important. We call performance testing. Then we have what we call AI-powered testing. The idea is machine learning, where we can use to generate test cases as well as predict any issue. So automation is now becoming very new in our field. Right. The next idea is quality assurance. So as I told you earlier, we have various different testing tools, especially for efficiency as well as the accuracy. And you have AI and machine learning comes in. Early days, we have humans, so we have separate team. We try to identify any anomalies and bugs in your code. Now we have automated tools. We are using artificial intelligence and machine learning to detect any anomalies and any problems in your code as well. Then test automation frameworks, especially there are tools like Selenium, Appium, so they can use to automate the testing task. Containerization is testing for isolated environments, especially I told you, like when you have a lot of dependencies with third-party software, which means like you develop a software, but then you are heavily relying on others. So then you better containerize and test them. Then cloud-based testing, what will happen if you implement something in the cloud? And we talk about the scalability. Depending on the growing demand, you may increase the resources for your software system. So that also should be tested. Right. And then collaboration, especially in software development, you work as a teams. So you need some software platform to work as a team. So therefore, you have some collaborative platforms as well. So all these provide, all these things will provide or improve the efficiency as well as accuracy of your product. Right. So next, we want to discuss about the test planning in agile environments. And I told you, like in agile, it's a continuous process. And then if you look at the testing as well as it also continues. We call continuous testing. So then there are different development environments, like there are like strategies we use test-driven development. So in the development itself, you consider about the testing. And then you have something called behavioral driven development. The IDs you have test together in the development. So therefore, when you have test plans, they are more dynamic, and then they are adapted to evolving requirements. And if you look at these teams and how they collaborate each other, so usually in agile teams, you will see both testers and developers, and they work very closely. Right. And then all these are integrated in your agile process. So normally we talk about the user stories. In each of these test cases, we accepted what criteria to be defined. So all these are designed before we finish the design part of it, not like in early you finish the design and then test it. Okay, so next, we need to focus on the standards and other matrices that we have used. So as a software industry, like any other manufacturing industry, like other products, we need some standards. So these standards will provide the consistency, interoperability, and prevent any issues in the IT industry. So there are some organizations dedicated to measure or quality or focus on the quality aspect of the IT industry. So ANSI is one such organization. They coordinate America for in voluntary national standards. And for example, they focus on the programming languages such as C, C++ language standards. Then we have IEEE, Institute of Electrical and Electronic Engineers. For example, the requirement gathering, they have specifications like IEEE 830 for system requirement specification. So in various parts of software development, you can have some standards, and then depending on your requirement, you can adhere some of these, which will improve your process. Then ISO, international standards. So we have ISO IEC 12207 for software lifecycle processes. Right. And I told you, like, you have to have some matrices to measure the quality of the software, developed software. A few things we can focus on. One is code quality. You can talk about one is as a code quality as a measurement. And then the other one is the performance. So based on these, you can measure the quality of your product. And especially this is very, very important, especially when you want to compare, right? So let's say you have two products or two implementation, and you have to decide on which one to select. So then you should focus on this, right? That's what we call quality. Right. Then to summarize what we have discussed, setting goals, especially tangible goal, meaning like what can be achieved, and then selecting appropriate matrices. How do you measure your quality of the product, like whether code quality or a performance? And some monitoring mechanisms are very crucial for software project success. For your information, usually in the project management, we usually say 80% of the time our software project fails and only 20% survives. So this is like traditionally we used to say. So which means you can see that although there are many software development projects are going, majority fail, because you have to be very careful on these ones. So therefore, as I told you earlier, to be successful, to be assured the quality of your system, so you have to have tangible goals, appropriate matrices, and continuous monitoring your progresses are very, very important. Make a note of this. Right. And then that's about the quality. And then the procedures and for the installation, that means in the deployment part, right? So that is what we are going to discuss here. So when you talk about your development, I told you about you can have tangible goals. So why we say that? Because sometimes development software incur huge cost. So you have to focus on the costs, schedules, the effort that you need to put, and as well as the quality, right? So each phase you have to actually monitor these, right? For example, when you want to assessment, you have to collect the data. So for example, sometimes you have to decide on whether you are going to do it on manual or you are going to do it on automated method, right? And then you have to have data analysis. Especially in this particular case, you have to analyze project, right? Some checkpoints, trends, look at the each individual components. Then installation. So you can do it in multiple different ways. You can direct install if it is a small systems, parallel mode for if you want to replace any existing systems, and phase approach for if you want to install in multiple servers. So depending on your requirements, you can decide how you may install this. Then documentation, again, very important aspect in software development. And there are various different types of documents you need to prepare as well. So one of the important one is system documentation. It's about the system itself. This is very, very important because especially when you are continuously developing a piece of software, usually your team changes, individual person changes, but you have to continue the development. So therefore, the system documentation is essential for a maintenance of a software system. And that's the way we can transfer knowledge of the development system from the start to end. And especially when you want to keep or improve your new members. So always you have new recruits. So first thing that they have to do is they have to familiar with the system. Then user guides and tutorials, especially these documents we prepare for the users, or we call end users, right? Now there's no real use if you develop a good software, but if the people are not using your software. So that's to improve that, we need user guides and tutorials. And this is very, very important to improve the user experience and understanding about your problem. Software system. Then nowadays, people used to reluctant to refer this. Therefore, I mean, nowadays, within the software itself, you can have, information. So this is called in-app help or tooltips. So for example, when you move your mouse in different parts of the software, you will get, different outcomes, some assistance. So it tells you about what it is. So this is called context-sensitive assistance. So in that way, I mean, end users, those who are using the software, they don't have to go and read user guides or that follow tutorials, and they can learn about the software by using the software itself. Right. With the growing demand, now we have a lot of video tutorials, screencasts, and we have software to develop these as well. And this is very important for the general users to understand how to use this software and to understand the features and how the workflows of this. Then the next one is API documentation, crucial for developers, especially how to use API and with some examples. Then final one, you need some collaborative tools and the documentations. For example, Confluence is one of them. Actually, at SLTC also, we have used Confluence to manage our software development as well as collaborations with some other partners. So we have finished one of the European Union projects called TEAL 2.0, where the SLTC was taking the main part of leading this, where the tool that we have used called Confluence. So the Confluence we have used to manage, starting from documentation to communication. So that means, so these tools are very useful. One is documentation, but some of them even provide other, services as well, even the communication tools. Right? Very, very important when you're designing very complex software systems. Then finally, maintenance and training. If you look at the maintenance types, we have corrective maintenance, especially once you develop the software, you have to address any errors and the issues. This is the common one if you have a new product. Then preventive maintenance is very, very important. In some of the applications, you cannot have any issues once you actually develop a system. So this is called preventive maintenance, especially mitigating security vulnerabilities and potential risk. We call preventive maintenance. Then improvement maintenance, which we call enhancing features and adapting to evolved user needs. Then change management, maintain prioritize list of changes and additions. Then implement continuous integration and continuous deployment. We call CI/CD, or streamline updates in agile development. And this is what I have mentioned earlier. Like if you use Git and GitHub, in GitHub Actions provide you, automate your task. While when you make an update into your code, it will automatically test it and then it will deploy. Then you can also use tools like Jira and Trello. It's common software nowadays using to track and prioritize the changes in the development and also software management. Last one, end user training, web-based tutorials, interactive courses or video demos, or we can use in-app onboarding or tool tips to help the users. Then supporting, now things have changed. You know that we are using now AI-driven chatbots for this. For instant assistant, I think most of the, nowadays you can see almost all the software now implementing chatbots, AI-driven chatbots for the support. Then knowledge sharing, you can have online forums, QA platforms, or community spaces. Then you can have monitoring and analytics, because so once you finish development and deployment, you have to continuously monitor your system. So monitoring and analytics is very, very important. This can be used as a starting point to see what are the issues in your software, right? And then again, analyzing your user feedback and all the metrics that we have discussed to prioritize improvements and enhancements. So these are like the last parts, but again, very important. So with that, we conclude what I want to discuss as a theory, which means we discuss with the implementation, development methodologies, and then we talk about the test, and then we also talk about the maintenance. So having said that, this part, the next part, we are going to do a small group work, group assignment, what we discuss object-oriented analysis, right? But before that, let's start with the attendance.